Almost anyone who gets into IoT starts out by buying an Arduino and downloading the Arduino IDE. And it's pretty straightforward. There's so much documentation. It's really the best place to start. You get an LED to blink, you attach a temperature sensor, you make a relay turn on or off. And then after a while, you're reading and you're getting more in depth. And you're starting to hear murmurs that the Arduino IDE is not the best place for you to be coding. But since you haven't used any other tools, you don't really know why you'd want to switch, or maybe you don't understand the rationale. So I sat down this morning and I was ready to spew all my opinions about PlatformIO in VS Code, why it is so much better than using the Arduino IDE. And just to sort of make sure my perceptions were correct, I took one more look and, my opinions changed. The Arduino IDE has improved quite a bit. Some of the things that to me were no-brainers are no longer no-brainers. But in the end, I did find one thing that is still the killer reason why you want to move away from that if you want to get any serious work done. Quick note, I'm using PlatformIO in VS Code. So some of the comments I'm making are not because of PlatformIO so much as the upgrades you get when you move to a more professional text editor. In this video, I'm going to do two things. I'm going to start by just going down the list of things I see as the key differences between the two tools. And I'm going to finish with one killer difference that supports my recommendation. And then finally, I'm going to show how to get started with PlatformIO, and I'm going to do it in a different way than the docs suggest. I'm guessing that, especially with AI as your partner, I don't see why it would take you more than 30 minutes to get your first sketch burned to your device. And, from my recollection many years ago, after I got through that 30 minutes, I never looked back. I never wanted to go back to Arduino IDE. It was just a much smoother experience from there on out. And so I think you should just take the leap and get there. Let's call this part 1 of 2. I'm going to go through the key differences. Moving to PlatformIO on VS Code gets you benefits not from PlatformIO necessarily, but also just from being away from the Arduino IDE text editor. Now, as I mentioned, it's gotten pretty good. The major point was several years ago, when you control D and you can select several words and do kind of a batch edit, that was not available. And also the opportunity to replace words across different files was not available. That alone is a reason to switch. That's gone. However, there's other things that are still major to your experience. For instance, in VS Code, the way you can add files and folders, just click and add, or delete with a right click. You can't do that with Arduino. You already know that when you start using the Arduino IDE that you're required to put your sketch in a folder that has the same name as the sketch. So what you get is a single folder with a bunch of folders that are named after your sketches, and then the sketches are inside. And then of course, the libraries are all pulled from one shared library. This works fine if this is all you need to organize, but it's not. You may have some board files, some PCB designs that you're working on, so you end up making a separate folder to keep those. You might have 3D printed boxes, and so you want to keep your STLs in a folder. You end up with your folders organized like this, and I think it's unambiguous that you do not want to be doing this. For any given project, you have to have all your files together for that project. So if you've got a gas sensor and you've got a relay board, for each of those, you need a folder, and you're going to keep your boards, your boxes, and your code, your firmware. For me personally, I like to have a couple different folders for my library. And there's a very good reason to have this. It's to maintain version control between the different aspects of your device. If the board is going to change the size, so is the box. Well, these are separate files, so the way you keep them synchronized is with Git repos. And then you're going to make a new Git commit so that that version stays together. If you're doing this in Arduino IDE, it falls apart. First of all, if I had gassensor.ini, I now have to name my folder gas sensor. Or I could change the name to code.ini. Another option might be to just put my gas sensor folder inside the code folder. By the way, I can no longer have my two different library files. I can only have libraries because that's required by Arduino. But the big killer is the fact that we've got a shared library resource. The whole point of Git is to maintain version control. However, you're linking a folder that's outside of your Git repo, so you cannot maintain control. PlatformIO does not pigeonhole you into this problem, so it's a much better tool for DevOps. PlatformIO is way better for version control. All the libraries that you install are installed in the project folder. They're not shared between projects. In Arduino IDE, it uses a single repository of libraries. So if you update the version on a library, that affects all of your code. In PlatformIO, you can actually call out the specific versions of your libraries. You can even call out specific versions of the ESP IDF, which runs underneath the Arduino framework. Even the platform that sort of keeps the family of boards, whether it's ESP32 or Arduino, those have versions as well. All of that can be locked into a project. And so you're not going to make changes in one project that's going to break things anywhere else. This last one, build flags, changed my life. It did, actually. So I rejected build flags for a long time, and I regret it. The build flags are used to signal to the compiler what code you want to include as you compile. And I thought, that's just way too complicated for what I'm doing. It's like, no, you know what's complicated? Complicated is having 4 separate pieces of firmware for 4 different temperature sensors when all 4 do the exact same thing. By using build flags, you can make the same piece of code do different things based on the flags that are present in your PlatformIO.ini. This reduces the version control burden significantly. You can have one piece of code doing 12 different things, and you can trust that it's going to work because you don't actually have to change the code once you already know it works. Better library management. I never could figure out how to effectively write libraries with my Arduino projects until I switched to VS Code. There's 2 ways to make the library work. One is you take all of your library files and put them in the same folder as your .ino code. But that becomes very cluttered. So the other thing you can do is you can put your files in a folder, and you can put that folder in a source folder, and then you can tell it, look in source library name, and it will pull out all your files. At which point, you can't see the folder anymore. My library files right near my main code and separate, but at that point I had to open up another text editor to edit the library while I was in Arduino IDE. That can't work. You can't be opening up 2 text editors. I'm not going to go much into the installation of PlatformIO. It's very well covered by a lot of other people. In summary, you have to have VS Code. That may require having Python. That may require Microsoft Build Essentials. Once you get into VS Code, you go to extensions, which are plugins, search for PlatformIO. You'll see the icon that looks familiar here. You click on it and install. It does take quite a while. It's bringing down a lot into your VS Code. And then when it's complete, you've got the PlatformIO icon on the left. That takes you to the home. I don't actually do much with this page. I've found that if you just investigate how this comes together from scratch, it makes a lot more sense. So that's what I'm going to show you here. Let's fire up your first PlatformIO project. We're just going to start with the minimum implementation. Let's see how quickly we can get some code burned onto your device. We're going to start with minimum implementation, minimum config file. So I'm just going to start a project folder here and bring up VS Code. You see there's nothing in it. So we can touch PlatformIO.ini, close code, and reopen it. And watch in the bottom left, you see PlatformIO kicks in. This is a neat feature. You don't need to tell PlatformIO to start. You just simply open up code in a folder that has a PlatformIO file in it, and it will turn on. Bringing up that error message we saw, of course we get an error, our config file is empty. Let's just add one line. We're going to add env, and we're going to give it a tag. Let's call it dev. It'll be clear in a few minutes what this is. It comes right back and says, by the way, we're missing a platform. But notice in the upper left, we've added a .pio file. This is where all the build artifacts are going to go whenever we compile. Anyway, it's asking for a platform, so let's go ahead and give it one. I happen to know I'm looking for Espressif32. Save, and again you see VS Code going to work. Now it wants a board. Board is not defined. So we're going to add the ESP32 dev. And this time when we save, you notice there's no errors. Now it's happy. It did add 2 more files. We've got the .vs code, which is just the area that holds sort of configuration settings for VS Code in this particular project. Then we've got the git ignore, which tells us that both the .pio and the VS Code folders are not going to be stored in our Git repository. So right now, PlatformIO.ini is all we have in this project. We could compile, however we don't yet have any code structure. So let's add the source file, which is where VS Code will look by default for a main.cpp. Now we'll go into what I'm guessing is your comfort zone. Anybody watching this video should be very familiar and comfortable when they see setup and loop, because they know that's the starting point of some cool project. This is the first time that PlatformIO is going to look like the Arduino IDE, which you're already familiar with. Now again, we could compile that code, except setup and loop is an Arduino concept, so there's one more thing we have to write down, which is the framework is Arduino. Framework, platform, and board. These may seem like new concepts, but actually you've already been delivering this information to the compiler just in a different format. Whenever you're in the Arduino IDE, you're always using Arduino framework. And whenever you come to the board manager and add a board, you're adding a platform. Then when you come to the top, you're selecting a board from your list of available platforms. So that's our minimum PlatformIO.ini. Let's go ahead and hit compile, and sure enough, we got a success. Let's go ahead and add some code and burn it to your device, and you'll see just how quickly we can actually get going on PlatformIO. Two things to mention here. I'm going to start by putting some serial prints in your setup and loop. You recall on the Arduino IDE, it defaults to 9600 baud for serial output, and you can go ahead and select the baud rate if you want it to be different. In PlatformIO, there is no default. You have to specify it if you want to print in your PlatformIO.ini. So I'm going to add monitor speed 115/200. And the second thing you'll notice as I type here is that we've got the squiggly lines. Our linter is picking up on the word serial. Of all the things that we are doing here, compared to the Arduino IDE, most steps are actually simpler. The one thing that gives you some additional work is that whenever you're specifically calling out a function that is Arduino specific, you've got to include the Arduino.h. So if you're using standard C, you don't need it. But whenever you dip into what are Arduino specific commands, you do. So let's compile and upload, and you'll see I'm going to speed through the compilations to keep the video going. So let's go back to the PlatformIO.ini. I'm just going to call it the .ini from here on out. Let's start by digging more into the environments. An environment contains a list of configurations. So in the .pio folder, we've got build and we've got dev. If we add an environment for prod and save, we've now got two environments. So when we compile, it's actually going to compile twice. First we do dev, and now you see it's added a prod folder. When it's done, you can dig into both these folders and see that we've got firmware.bin. That's the actual firmware that's going to go to your device. And what's nice about it being right here is that your project can also have some custom scripts you've written that can be used to grab that firmware and send it off to the cloud for firmware updates or any other automations that you have. Keep in mind we've got this git ignore, so your firmware is not going to go to your git repo. At the bottom we've got an option to select environment. So you see that if we just select prod and compile again, it's only going to compile one version, the prod version. When we do go to select on top, there's a bit of a hint. It's not very specific, but what it's telling you is another option is the default. So if we haven't selected, it's going to go with default. And right now there isn't a default, so it's telling you, hey, go ahead and specify what the default environment is. If you don't specify default, it's going to compile both of them. But we have the option of just saying, look, if I haven't specified, go ahead and give me dev as your default. We select that default and compile. Now instead of prod, we do get dev. So we have two environments, but they're actually exactly the same, right? This is where we get into build flags. Let's add some conditional code. We've got two options. We can use the if def or the if ndef, which is if not defined. If we have defined working hard, we're going to put an extra serial print in our setup. And in our loop, if we have not defined working hard, we're going to use our original serial print. But if we have defined it, we're going to use a new one. Notice that as soon as the linter has time to review, you'll see that the code above and our second line below, both are sort of faded out, and that's because working hard is not defined. So as of right now, these are not going to be included in the compilation. Now, if we go ahead and define working hard, that changes everything, right? So it's going to flip. We're going to define these flags not in our code, but in our .ini. As you saw, we can use those definitions to selectively compile certain parts of code during compilation. With build flags, it allows us to make those selections without actually changing the code. Anyone who's had a typo in their life knows there are advantages to not changing the code whenever we want something different to happen. When we select prod and burn it, we get those alternate serial prints. In practical reality, this is really beneficial when you have two different devices that do exactly the same thing, but maybe on one board you have routed to different GPIO pins. Well, it's the exact same code is required for that device. However, you want to change up the pins on compilation. Build flags are excellent for things like that. So we come back to our INI and realize that we've actually got some redundancies, and it turns out there is a way to clean that up. We simply just define a blank env, and we put those values under that blank env, and that way those values will apply to any subsequent environment that we've defined. So let's talk about third-party libraries. I think they're a lot easier here in PlatformIO than they are in the Arduino IDE. In Arduino IDE, you've got to go to the Tools Library Manager, and you've got to find your library and install it. In PlatformIO, you simply add the library name to your .ini, and it will pull that library down automatically. You can hardcode your version number to make sure you're not always pulling latest. And you notice that in our build folder, we now have our library saved. This is one of the great advantages over Arduino IDE. Any libraries you pull are going to be specific to that project. You're not going to have one central library manager where libraries can get overwritten and break your code. You can have several build flags. Syntactically, you're allowed to just go to new lines, and it's a lot easier to organize them that way. Build flags, libraries, you're often going to have more than one, so I like to just set them up this way visually. I mentioned before I'm a big fan of the flexibility you have regarding your folder structure in PlatformIO. If you were to create a project using the PlatformIO builder, you would have gotten 4 folders here in your project. You've gotten source, gotten lib, include, and test. Lib is the default path for any libraries you want to add in. You're always going to have to give the library a name, give it a folder to contain your library, and then within that folder you're going to have your .h's and .cpp's. Of these folders, I'm not going to use test, I'm not going to use include. I actually don't want to use lib. My preference is to have one folder for standard libraries that are the same in all my projects, and another folder that has device-specific libraries. So I want to have lib standard and lib device. But these folders are not automatically known to PlatformIO, so you have to go to your INI and add lib extra durs and list them out. With this done and saved, I can now add libraries to either of these folders, and the compiler is going to find them at compile time. So let's do it. This is the big benefit of PlatformIO. Once you see how the folders are structured, it makes understanding libraries so much easier, and you're going to be off to the races writing your own libraries if you're not doing it already. This is not a tutorial on making libraries. I want to just make the most generic library possible to just show you that I can lay out these files right here in front of me while I'm working on my main.cpp. When you're developing your own libraries, they're always in development, and it's nice to have them here in a separate folder where you can develop them. Specifically, I'll use git submodules to keep the library separate from the main code so that I can push changes and then distribute that to my other projects without changing the main source code. I'll blow through the writing of the library here. It's not going to do anything other than just expose a couple of serial prints. Then in our main.cpp, we'll include the library, include test.h. We'll create an instance of the class, and then we'll use that instance to call our serial print. We compile, and there it is. See, my library is working. Just to reiterate the point of how much easier it is to develop like this, I'll just add one more function and I'll call it in my loop. And so you can see with this setup, we can add a lot of powerful functionality without the complexity getting out of control. Gone are the days when you have 12 tabs going across in your Arduino IDE and you're trying to make sure they're all organized. I'm running out of battery. Okay, well hopefully this convinced you to switch over to PlatformIO. I'm Larry, thanks for watching. I'll catch you in a week.